2D figures test retake. Number one, find the total area in square centimeters. Round to the nearest whole number. So here we see that we have a semicircle, and so we're going to find the area of that semicircle using the formula 1/2 pi r squared. We're just going to plug in the radius, which is half of 24. That's where we get the 12 from. And let's see, so that'd be 72 pi for the semicircle area. I'm going to leave it in terms of pi for now because we still have to subtract. And then this is a trapezoid. The area formula for a trapezoid is 1/2 times the height times the sum of the bases. So that's going to be 1/2. The height is 24. The full height, we want the full height, 24. The bases would be 34 and 16. All right, and when we multiply all of that, we should get 600. Okay, and did I say subtract earlier? I meant add if I said subtract. So now we're going to take the 72 pi, we're going to add it with the 600. So 72 pi plus 600, and that will give us a decimal, obviously. So we're going to round to the nearest whole number. Okay, so that's 826. After the decimal is a 1, so we can round it to 826. Okay, try number 2. Number 3, what is the sum of the measures of the interior angles in a regular pentagon, excuse me. So we have this regular pentagon, pretend it's regular, meaning all the sides are equal. So we want the sum of the measures of the interior angle. So you can do this with the formula, which is 180 times n minus 2. N would be the number of sides. Okay, so that would be 180 times 5 minus 2, which would be 180 times 3. And 180 times 3 would give us 540 degrees. Go ahead and try number 4. Number 5, what is the area of the shaded portion of the parallelogram shown below? So technically, you could just find the area of this trapezoid. I'm not going to do that so that I can help you with number 6, but you could just do that and make it simpler for yourself. But I'll do the area of the entire parallelogram, and that would be base times height. So that would be 30 times 12, which is 360. Then I will do the area of this missing triangle, and that would be 1/2 base times height. So the base of the triangle is 9, excuse me, 1/2. The base of the triangle is 9, and the height is 12. That'll be 54. So since this triangle is missing from the parallelogram, it's not being added on, it's being taken away, we're going to subtract. And that'll give us 306. Go ahead and try number 6. Number 7, find the area of the regular polygon. Area formula is 1/2 apothem times perimeter. The apothem is 16.5. The perimeter, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides, and each side is 12. And then we're going to multiply it out, see what we get. We get 891. Go ahead and try number 8. Number 9, what is the total area of the figure below? I'm going to break this up into a triangle and a rectangle. So for the rectangle, area is length times width, which is going to give us 9 times 13. That's 117. For the triangle, area is 1/2 base times height. So that would be 1/2 times, okay, well, the base is not 20 because this triangle is only part of the entire base of this irregular shape. Let's see, we know this part is 9, so this part has to be 11 because 9 plus 11 is 20. And then the height of the triangle is not 8, it's not 13. See, this part over here is 8, which means 13 minus 8 is 5, so the height is 5. So half of 55 is 27.5. We're going to add those together because as you can see, this triangle was added onto the rectangle. It was not taken away. That'll give us 144.5. Go ahead and try number 10. Oh, and real quickly, I'm so sorry. To find the height, you would have to use Pythagorean theorem, and that should give you 3.746 for the height of that triangle right there. Number 11, and a circle is inscribed inside a square. The radius of the circle is 10. So radius is half the diameter, so that's 10. Find the area of the shaded region. Okay, so since this is to find the area of the shaded region, it's a subtraction problem. So let's find the circle's area first. Pi r squared is for a full circle. So that'll be pi times 1. Oh, sorry, 10 squared. I'm jumping the gun. 10 squared is 100. Boom. So that's 100 pi. I'm going to leave it in terms of pi for now. Now we're going to do the square. Area formula for a square is length times width, or you can just do one side and square it since they're the same number anyway. Now, one side length is going to be 10 plus 10, right? Because 10 was only the radius. So that's going to be 20 to the second power, which is 400. All right, so now we're going to take those numbers and subtract them. And we're rounding to the nearest whole number. And okay, and that's going to give us 86 when we round it. Go ahead and try number 12. 13. Find the area of the regular hexagon shown below. Again, this is a regular polygon, so we're going to use this formula. The apothem is 8 square root of 3. The perimeter is 1, 2, 3, 4, 5, 6 times 16. Okay, and that will give us 665.11. It didn't tell us where to round, so I'm just going to round it to hundreds place. Go ahead and try number 14. Number 15, the dimensions of a main bedroom are given below. The owner would like carpet to be placed in the bedroom. How many square feet of carpet are needed to cover the bedroom floor? So again, we're going to break this up into two shapes that we can figure out the area of. So the area for this one is just going to be length times width because it's a rectangle, so that'll be 11 times 7, which is 77. The area of this one over here is going to be length times width because it's a rectangle. I don't know if it's a square or not yet. Let's see, we got 6 times. Okay, that's also 6 because this is 5 and this is 11, so that means the missing part must be 6. So it was a square, so 6 times 6 is 36. Then we're just going to add those two together. And we get 113. Go ahead and try number 16. Number 17, regular polygon has radii and apothem as shown. Find the measure of each numbered angle. So the first thing I want to do is count, see how many sections this is broken up into. 1, 2, 3, 6, 7, 8. Okay, so to find the measure of angle 1, we know that all the way around the circle is 360 degrees. And we know this is broken up into 8 equal sections. So we're going to go ahead and divide that out and get 45 degrees for angle 1. Angle 2 is half of angle 1. So 45 divided by 2 give us 22.5 degrees for angle 2. And then the measure of angle 3. I mean, there's different ways we could do it. I would say I would just take, this is 90. So for the measure of angle 3, I would do 90 minus 22 point, Lord have mercy, help me, help me. Minus 22.5, and that should give us 67.5 degrees. Go ahead and try number 18. Number 19, calculate the area of a regular polygon with the given side length. This time we don't know the apothem measure, so I'm going to put an A there. All right, so we're still going to start with the area of a regular polygon formula. Again, we do not know the apothem as of yet. We do know that this is a 1, 2, 3, 4, 5, 6 sided shape, and that one of the sides is 10 feet, so the perimeter is 60, but we still have to figure out the apothem. Sorry for the sniffs. Okay, this is a right triangle here, so we can use some right triangle rules, some trigonometry if you would, to find the measure of angle A. Since this is a hexagon, I know that this is 30 degrees. I know that this is 60 degrees. Okay, so this is, oops, 60 degrees. This is 30 degrees. Since we know that, we could use trigonometry. We could use sine, cosine, or tangent, or we could use the 30, 60, 90 rules, the 30, 60, 90 special. I'm writing it down just in case you forgot what it is. Right triangle rules, so you know where to look in your notes. And when we do that, sorry, this is 5. We know that that's 5 because this whole thing is 10. Half of that would be 5. And we don't know this. All right, so label your sides. This is the short leg. This is the hypotenuse. And this is the long leg. The relationship between short leg and long leg is if you take the short leg and you multiply it by the square root of 3, that'll equal the long leg. So that'll be 5 times square root of 3 equals A. So that's what I'm going to plug in up here. And let's work it out and see what we get. Okay, so that would be 150 square root of 3, or in decimal form, 259.81. Go ahead and try number 20.